Solving rational functions. Okay, pause your video and write down anything you need to on this slide, and then restart it, and I will explain it. All right, our steps for solving rational functions. First of all, we're going to start by factoring all parts in order to help us make common denominators. We might be doing this by canceling out common factors or multiplying the top and the bottom by something in common. It just kind of depends on what we're given. Step 3 is going to be to set the numerators equal. So once our denominators are the same, we can just focus on the numerators. Step 4 is going to be solve. And then we wanted to make sure we check to make sure our answer is not restricted from the domain. All right, the first problem here, we need to factor everything, which I can't factor any parts, so we'll skip that. Next one is to make common denominators. First of all, this 3 is over 1. Anytime you don't have a fraction, you can put it over 1. My denominators right now are 6, 2, and 1. So I'm going to use a common denominator of 6 because they can all divide into 6. So this fraction right here, I'm going to multiply the top and bottom by 3. And then this other fraction, I'm going to multiply the top and bottom by 6 so that I have common denominators. Now that my denominators are all the same, I can just focus on the numerators. So I'm going to take this equation, x plus 15 equals 18, and I'm going to solve it. And there's my final answer. The only thing I have to check is my restricted values. Since there aren't any x's in the denominator, I don't have any restricted values, so 3 is just my answer. Okay, this next problem, same idea. We're going to start by factoring everything, which there's nothing in here to factor. Then I'm going to move to common denominators. I see I have an x in 2 of my denominators, so I'm definitely going to want to put an x in this denominator. And I've got a 3 and 2 2's, so I'm going to need to make those into 6's because 3 and 2 both divide into 6. So this first fraction, I'm going to multiply the top and the bottom by 2 so that I have 6x on the bottom. The second fraction, I'm going to multiply the top and bottom by 3 again so that I have 6x on the bottom. And the last one, I'm going to multiply the top and bottom by 3x. Remember, I needed to put an x in that one so that it will be 6x. Okay, so I'm going to go ahead and distribute this 2. I have 2x minus 6 for this first one. The second one, I'm going to have 9 over 6x. And then I have 3x over 6x. Common denominators all the way, so now I'm just going to focus on the numerators. I have 2x minus 6 plus 9 equals 3x. And I'm just going to solve this equation now. So I have 2x plus 3 equals 3x. Once I combine these like terms, subtract the 2x over, I get 3 equals x. So my answer here is 3. Looking back at my denominators, I had just numbers times x, like 2 times x, 3 times x, 6 times x. So my only restricted value is 0. Since that wasn't my answer, I am good to go. Okay, next one, I do need to make common denominators again, and I'm going to start by factoring, because I noticed this x squared minus 9 is a difference of squares. So this is actually x plus 3, x minus 3. That's going to help me with my common denominators. Since this denominator has an x plus 3 and an x minus 3, that's probably what I'm going to use for my common denominator. So this first fraction, I'll multiply the top and bottom by x plus 3. And the middle fraction, I'll multiply top and bottom by x minus 3. So whenever I rewrite this, I have x plus 3 over both of those for the first fraction. x minus 3 over both of these for the second fraction. And then this one's just going to stay the same because it was already x plus 3x minus 3. Denominators are all the same, so I'm just going to set my numerators equal. So I have x plus 3 plus x minus 3 equals 6. X and x is going to make 2x. These 3's add up to 0, so they cancel out. I did not plan for all of these answers to be equal to 3. But I got 3 again. Now, looking back at my denominator, notice that my restricted values would be 3 and negative 3. Since x can't equal 3, then my answer is actually no solution. So you always have to check to see if the answer you got for x, if it's a restricted value. If it is, you're going to have no solution. All right, next one, we need common denominators. I'm just going to multiply this one by a factor of x minus 5 on the top and the bottom. And then this one by a factor of x plus 5. And now I have my common denominators because they both have an x plus 5 and an x minus 5. I'm going to go ahead and distribute my 4 and my 3 into this next step. Once you have common denominators, you can just look at the numerators. And now we're just going to solve this. My restricted values here are just 5 and negative 5 because my common denominator was x plus 5, x minus 5. So my final answer is x equals negative 35. Okay. On this next problem, notice again that our 3 doesn't have a denominator, so I'm just going to put it over 1. Think of this as kind of like a free spot. So we don't need to make sure that there's a 1 in every denominator. It's kind of like just an open space. I notice that my first denominator has a p in it, and then my other one has a factor of p plus 2. So my common denominator here is going to be p plus 2. I'm going to have both of those parts in each denominator. So the first fraction, I'm going to multiply top and bottom by p plus 2. My second fraction, I'm going to multiply top and bottom by p. And then the third one needs to have both a p and a p plus 2. Whoops. I don't know where that x came from. So my next step, I'm going to go ahead and distribute this 4. I'm also going to distribute this p. And then over here, be very careful, but I'm just going to distribute the 3p. Now that I have common denominators, I can set all of my numerators equal. And I can solve. So 4p and negative 2p is going to make 2p. Notice I have a 3p squared on both sides. Those are going to cancel out once I subtract that over. Subtract 2p. Sorry, I'm running out of room here. And then divide both sides by 4. We get p equals 2. Okay, looking back up at all of my denominators, my restricted values, I'm going to put that over here since I kind of ran into that area, are going to be 0 and negative 2. It's 0 because I have a factor of just p down there. And then the p plus 2 would be a 0 if it was equal, if p was negative 2. So my answer if p equals 2 is fine because 2 is not a restricted value.